In this video we'll demonstrate the new linear contact capability available now in FEMAP and NX-Nastran version 4. We'll start with a geometry model of a linkage comprising three solids joined together. Using FEMAP's powerful grouping functionality, we can easily separate these solids into different groups so they can be viewed independently of each other, and this will make the contact modeling much easier. So we essentially have two links held together with a pin with a couple of spacers. One link will be fixed and the other will be loaded with a tensile bearing load. We'll zoom up on the pin here and start to define the contact segments using the Model Contact menu command. Then we proceed to select all of the surfaces that will be in contact around the circumference of the pin and on the sides of the spacers. Then we just give it a name and select OK. Moving on to the next component, we do the same thing. Again, the surfaces on the inside of the holes are selected and the sides of the lugs too. And we give this the name free end and select OK. Then finally the contact surfaces of the next link are selected in the same way. Besides surfaces, contact can also be defined on curves and elements, and multiple pick options exist, so the entities don't have to be picked one by one. So we give this the name fixed end and select OK. And so you can see the contact surfaces highlighted here. The next thing to do is to create a contact property. Again, this can be found in the Model Contact menu. We give it the name Linear Contact and select the Linear Contact button. This opens a dialog where the linear contact properties can be changed, but the defaults usually suffice, so we click the Defaults button and move on. Finally, we need to set up the contact pairs, which refer to the contact property we've just defined. There are two contact pairs in this case, between the pin and the two links, and they are defined using the master-slave convention. And so that's it. That completes the contact definition. Now we move on to finish up the analysis model definition, first of all applying a surface constraint to the end of the fixed link. Now we'll mesh the model, selecting all solids, taking the default mesh attributes, picking up a standard material property from the material library, and so we see the final meshed FEA model. The final modeling consideration is the loading, and for this we'll use the API to apply a spider to the free end lug using the Tools API Programming menu pick. This allows us to browse to the FEMAP installation directory where a number of delivered API programs reside in the API directory. The one we want is the Visual Basic program in the Spider API directory. When running this program, a list of nodes is requested, which we select using the On-Surface option. The program then calculates the centroid of the group of nodes and applies rigid elements to a new node created at that centroid. The only thing we need to do then is to apply a nodal load to that node in the middle of the spider. And that completes the pre-processing. Now we'll just clean up the display and submit the analysis. In Model Analysis we'll select a new analysis set and verify that the boundary conditions created earlier have been included correctly. Then set the job to run using NX-Nastran. You must remember that this is a linear contact analysis only, so we're limited to small displacements and linear material properties. So once the analysis is completed, we can go and look at the results. We'll clean up the display a bit by switching off the deform model, setting displacements to actual deformations, and we'll define a section cut to see what's going on at the pin joint area of the model. This will allow us to get a much better insight into the internal behavior of the contact region of the model. And we zoom up and exaggerate the deflections. We see the contact quite clearly and the model opening up due to the loading as expected. And there we have a simple linear contact example.